Hi guys, this is grade 11 Euclidean Geometry. I know most of you are having a challenge when it comes to this topic, and this topic is the most easiest topic in paper 2 of mathematics. It's the most straightforward and easy topic, and it remains the same until grade 12. And also it's recommended that if you're a grade 12 student, just go through this basics and you will have a much good understanding when it comes to the one in grade 12. And it's more or less the same thing from grade 11 and grade 12. 60% of the things that are in grade 11, you find them in grade 12. So it's recommended that you go through this basics as well. So before we go to the first theorem, we have to go through the basic terminologies that we'll be using throughout this topic. So here we have a circle, and from the bottom of the circle we see we have an arc. An arc is something like this. I believe we all know what an arc is. So it can be in this form, it can be in this form, it can be in this form, as long as it looks like a curve from the circle. So this is called an arc. And then we have a chord. A chord is a line drawn from the other side of the circumference of the circle to the other side of the circle So it's called a chord. And we have a diameter. A diameter is different from a chord. And how is it different? Because they are both lines that are drawn from the other side of the circle to the other side of the circle. The diameter is different from the chord because the diameter passes through the center of the circle and it cuts the circle into two equal halves. And a diameter is made up of two radius. The first radius, the second radius, and when they are two, they are called radii. You'll get to understand this when we dive deep into the other theorems as we go. And then this is a diameter, a line drawn from the center to the circumference of the circle. It's a radius. It can be drawn from here to here. As long as it's drawn from the center to the circumference of the circle, it's going to be a radius. And we have a secant. A secant is a line drawn outside of the circle, passing through the circle to the other side of the circle. Then that's called a what? A secant. And we have a tangent. A tangent is a line that touches the circle at one point. It only touches the circle at one point. So that's a tangent. Let's go and see how we can apply these terminologies in the first theorem. All right, let's get into theorem 1 in our Euclidean geometry topic. So theorem 1 states that the perpendicular drawn from the center of a circle to a chord bisects the chord. This what basically means? It means that if OM, so you can see OM from our diagram, right? OM perpendicular to AP, perpendicular lines looks like this, they look like this, and they form a 90-degree angle in between where they meet, So it can be 90, this is 90 on this side and 90 on the other side. So these are what? Perpendicular lines. They can also be dimensioned like this. They can be like this, and also this side will be 90, 90. Both sides will equal to 90. And let's get into what we have in the board. So if OM, the theorem says if OM is perpendicular to AP, that means M1, angle M1, the angle M1, and this other angle M2, they are both equal, and they equal to 90 degrees. So here we see that there's angle M1, M2, and we've just mentioned that when perpendicular lines meet, or where they meet, they form a 90-degree angle on the or both sides. So here this angle will be 90 and this one will also be 90. Then AM will bisect MB, or sorry, not AM, AM will be equal to MP. AM equals to MP. If we say something bisects each other, or bisects something, if I say this line bisects the line AP, this line bisects AP, that means it cuts AP into two equal halves. I'm sure we are all clear with this one. And then what we have here, we are given that O is the center, and also will be given that OM is perpendicular to AB, and lastly A, for the sake of space, let's write it here. AB is a chord. So you remember from the basics, here we are using the term chord. So if you don't know what a chord is, go back in this video. At the beginning of this video, you will see what a chord is. AB is also a chord. Now we'll be required to prove that AM is equals to MB. Required to prove. We're required to prove that AM is equals to MB. So whenever we prove, triangles are our easiest way to prove such questions. So we'll have to construct two triangles in this diagram that we have. So our construction will be that join OA and OP. So you see, if we join OA, this will be OA, and we join OP. You see, now we're forming what? We're forming two triangles. Triangle OAM and triangle what? OBM. So we can see we have triangle OAM and OBM. We have two triangles now. So we want to prove that this line AM is equals to MB. So we will use what? We'll use congruency. We'll have to prove at least three things, that maybe two angles on this triangle equal to two angles on that other triangle and the side. So those are three conditions. So we need three conditions in order for us to do what? To prove this theorem. So for the sake of space, I don't have enough space. Please write this down and let us continue proving. You can just pause the video and write this down. And then now we have to prove from these triangles. So the first condition, we have OA equals to OB. OA equals to OB. OA equals to OB. What's the reason? This is a radius. You see, it's a line drawn from the center to the circumference. Also a radius, a line drawn from the center to the circumference. So the radius are all equal. So it's called what? If there are two, they are called what? Radii. So your reason here will be, radii. And then let's look at another condition. The second condition is what? Angle M1 equals to angle M2 equals to angle what? sorry, they equal to 90. Angle M1 equals to angle M2 equals to 90 degrees. And this we are given. If they tell you that lines are perpendicular, by default you should know that the angles in between are what? Are 90 degrees. So this is 90 and this is 90. And if you can look at this, it's a straight line. 90 plus 90, they give you 180. So angles on a straight line are supplementary, or they add up to 180. So this one is given. We are given that M1 is equals to M2 because both of them, they are what? Equals to 90. And then the last condition, not the last, but the third condition, our final condition, will be that OM is equals to OM. OM equals to OM. The reason for this, OM is common in both triangles. Can you see that? OM is in this triangle and also in the other triangle. So it's what? Common. OA, let's go back to the first condition. OA is equals to OP. OA equals to OP. So on this triangle, we find the side that equals another side on that other triangle. That's the first condition. Second condition, on this triangle, we find an angle that equals to another angle on the other triangle. So on this triangle, we have 90. And on the other triangle, we also have 90. So this is our second condition. Our reason was that it was been given. And the third condition, we find that OM is in both triangles. It's in this other triangle and that other triangle. So now we can conclude that triangle OAM is congruent to triangle OBM. What's our reason? So I'll make another video. You should check another video where we are proving congruency and similarities. So you don't have to worry about this. But in this theorem, this is how it's gonna be. It will only change the values, the letters. Here they can change it to B, or maybe here they can change it to, but the format is still the same. You just use the same method throughout. So our reason for saying this triangle is congruent to the other triangle is that we have proved a right angle. So triangle that has a 90 degree is called a what? A right angle because of the 90 degree. So we have proved that they are both right angle triangles and they have hypotenuse and then a side. The side that is what? That is common. So if you are proving similarities between two triangles that are 90 degree or that are right angle triangle, your conclusion will always be right angle hypotenuse side. Right angle hypotenuse side. If the triangles are what? Right angled triangles. And then now if they are congruent, that means this line AM is also equals to MB or BM from the other triangles. Therefore, AM is equals to BM. You have proven that if OM is perpendicular to AB, AM will be equals to MB.